Hello, this video is a tutorial video which show you the implementation of a bendable head massager using geometry nodes. Before starting tutorial, here is the result product. You can use geometry nodes to set up the target collection and enable the massager to bend around that target. Moreover, you can not only adjust the number of legs of the massager, but also control the thickness of the legs, and change the color of the legs by changing the color random seed. The video I uploaded in the past was about a massager implemented using rigging, because I didn't come up with the mathematical implementation of head massager at that time. In the next video, I'm gonna compare the rigging version and the geometry nodes version, so I hope you also watch that. In this video, a simple mathematical idea was implemented using geometry nodes. Let's get it started. Oh, if you don't want to see this cute anime girl, jump to next timestamps. Let's get it started. Please change the direction of the curve is upside down like this. The raycast node is the key node in this tutorial. In this object info node, you should check relative, instead of original. When raycasting upwards from the endpoint of the curve, hitting the target object means that the endpoint of the curve is inside the target object. In other words, this indicates that the curve should bend. In this tutorial, the bending of the curve will be implemented using the rotation of the curve's endpoint around the start point. First, let's decide which axis to rotate around. The axis vector for rotation is determined by the cross product of the curve's directional vector and the hit surface's normal vector. Here, there is no problem using 0, 0, -1 as the curve's directional vector in implementing the bending logic. Keep that in mind. The order of calculation is important for cross product. Second, let's decide how much to rotate. The amount of rotation is determined by how deeply the curve's endpoint is positioned in the target object, and the angle between the curve's directional vector and the hit normal vector. As you can see, the more parallel the directional vector is to the hit normal vector, the more the endpoint rotates. The deeper the endpoint located inside the target, the more rotation needed. Easy, right? The multiplication of these two values provides some plausible approximation for the rotation of the endpoint. If you are interested in this approximation, look at this explanation. Because we want the endpoint to be on the surface, we are going to use the geometry proximity node. In reality, the endpoint is slightly above the surface, not right on the surface. So we can use vector scale node to control the distance. We can set multiple objects as targets by using collection info node, like this.
We can set multiple objects as targets by using collection info node, like this.
Instead of the curve line, let's apply a bezier curve as the input. It's important that the y delta between start and end of the curve should be roughly 1, as shown in this video. Wow. Wow, it's very interesting that we have to rotate the left handles only, without the right handles. Congratulations! You made it! In the next video, I'm gonna compare the rigging version and the geometry nodes version, so I hope you also watch that. Thank you for watching. I'll see you guys very soon. Later.